There's a planet out there that shouldn't exist. It's 730 light-years away, orbiting a sun-like star. A year lasts 18 hours. When astronomers first spotted it in 2020, they thought this was an instrument mistake, because what they found breaks every rule we have about how planets form. Meet TOI 849b, the biggest solid planet we've ever discovered, and its story is stranger than you'd think. Let's talk numbers. TOI 849b has 40 times Earth's mass packed into a body only 3.4 times wider than our planet. That makes it denser than Neptune, heavier than Neptune, but roughly the same size. Here's the problem. A planet this massive shouldn't look like this. When planets reach about 10 Earth masses, something kicks in that astronomers call runaway gas accretion. Gravity becomes strong enough to pull in hydrogen and helium from the surrounding disk. Fast, within a few million years, you get a gas giant, something like Jupiter or Saturn, wrapped in thick atmospheres hundreds of times more massive than the rocky core beneath. TOI 849b is opposite. It has 40 Earth masses and should be drowning in gas. But when researchers measured its atmosphere using the HARPS spectrograph in Chile, they found almost nothing. Maybe 4% of its total mass at most. The rest? Iron, rock, and water ice. David Armstrong from the University of Warwick put it simply: it's very difficult to make a planet as massive and dense as TOI 849b without it becoming a gas giant. Something in that standard process went wrong. But here's where it gets weirder. TOI 849b doesn't just break formation rules, it's sitting in a place where planets like it almost never exist. Astronomers call it the Neptunian desert. It's a region close to stars where Neptune-sized planets are shockingly rare. Surveys have identified only a handful of exoplanets residing deep in this desert, including TOI 849b, NGTS 4b, and LTT 9779b. Most planets at that orbital distance are either massive gas giants or small rocky worlds. The middle ground? Empty. And TOI 849b sits right in the middle of that emptiness. Its orbit takes 18 hours. That puts it scorchingly close to its star, about 1.5% the distance between Earth and the Sun. Surface temperature? Around 1,500 degrees Celsius, hot enough to melt rock. Close-in planets like this usually fall into two camps: hot Jupiters, which are enormous and gassy, or super-Earths, which are small and rocky. TOI 849b fits neither category. It's the size of Neptune, but built like Earth. That combination is so rare that some scientists think we're looking at the first confirmed example of something we've only theorized about: a chthonian planet, the exposed core of a gas giant that lost its atmosphere. So what happened? Where did all that gas go? There are three main theories, and each one tells a different story about disaster. Let's break it down. The first one: photoevaporation. TOI 849b. The planet orbits so close to its star that it's blasted with intense ultraviolet and X-ray radiation. Over billions of years, that radiation heats the atmosphere until hydrogen and helium molecules moved fast enough to escape into space. However, initial calculations suggested photoevaporation rates alone might not provide the mass loss needed to remove a roughly 280 Earth mass envelope from a Jupiter-like gas giant. Something else might have contributed. What that could be remains a mystery. Here is the second theory. Imagine two gas giants, each several times the mass of Jupiter. They slam into each other at thousands of kilometers per second. a planetary collision. The impact would release enough energy to blow away most of the atmosphere, leaving behind a dense, superheated core. It would be catastrophic. But it would explain why TOI 849b is so massive yet so bare. Then there's the third possibility. It never had an atmosphere to begin with. Maybe TOI 849b formed late in its system's history, after most of the gas in the protoplanetary disk had already dissipated. Or maybe it carved out a gap in the disk as it grew, isolating itself from the hydrogen and helium it needed. In this scenario, TOI 849b isn't a stripped gas giant, it's a failed one. A planet that stalled before it could finish growing. Each theory has problems. Each theory has evidence. And right now, we don't know which one is right. But here's the big part. Why does TOI 849b matter regardless? Imagine Jupiter, Saturn, Uranus, Neptune. They're all wrapped in atmospheres thousands of kilometers thick. We can't drill through them. We can't sample their cores directly. Everything we know about what's beneath those clouds comes from computer models and indirect measurements. The problem? We've never seen inside a gas giant. TOI 849b might give that chance. It changes everything. If this really is an exposed core, we're looking at the guts of a giant gas planet laid bare. The innermost part of Jupiter. The materials that were there before hydrogen and helium ever arrived. NASA's Juno mission, which studied Jupiter's gravitational field, suggested an upper limit of about 25 Earth masses for Jupiter's core. But TOI 849b is even more massive than that. Researchers hope to study TOI 849b's thin residual atmosphere, if it has one, using future telescopes like the James Webb Telescope. Any atmosphere would be continuously replenished from the core itself, evaporating under the intense heat. A living atmosphere, one fed directly by the planet's interior. That means the composition of the atmosphere would tell us the composition of the core. Think about that. By analyzing an exoplanet 730 light-years away, we could learn what's inside Jupiter. That's not just impressive. That's a window into planetary interiors we've never had before. But the bigger question: how did this happen? Planet formation theory has been refined over decades. We understand how dust grains stick together. We understand how rocky cores grow. We understand runaway gas accretion. But TOI 849b, it doesn't fit any of those models cleanly. If it lost its atmosphere through photoevaporation, why didn't other planets in the Neptunian desert lose theirs the same way? If it collided with another planet, where's the debris? If it's a failed gas giant, why did it stop growing at exactly 40 Earth masses? Christophe Mordassini from the University of Bern led the theoretical analysis. Think of it like a cosmic traffic jam. The planet might have opened a gap in the swirling disk of gas around its star, gravitational forces pushing material away, cutting off its fuel supply. Or picture a construction site that runs out of materials halfway through. The disk could have simply run out of gas at the exact moment this planet needed it most. Both scenarios are possible. Both are rare. And that rarity might be exactly why TOI 849b exists in the Neptunian desert, because whatever created it required a perfect storm of unlikely events. Discoveries like TOI 849b force us to rethink what we know. They challenge models. They open new questions. The universe is stranger than our theories predict. This isn't just about one weird planet 730 light-years away. It's about understanding planetary systems, how they evolve, how they break. It's about figuring out whether cores like this are common or vanishingly rare. What happens when things go wrong during planet formation? TOI 849b is the most massive rocky planet ever observed. 40 Earths crammed inside, sitting in a desert where almost nothing exists. It might be the first exposed planetary core ever found. We don't have all the answers yet, but that's what makes this exciting. And TOI 849b, it's one of the most intriguing pieces we've found. If you're fascinated by planets that challenge everything we thought we knew, the kind that make scientists go back to the drawing board, hit that subscribe button. The universe is full of worlds that don't play by the rules, and we're just getting started finding them.